In this video, we're going to be talking about the difference between displacement and total distance. So let's define both of those and then we'll do some examples. Displacement is talking about when an object changes position relative to where it started. So a displacement can be positive, negative, or zero. Let's talk about what each of those mean. A positive displacement would mean that our object moved in a positive direction, meaning moved to the right or moved up. A negative displacement would mean that our object was either moving left or down. And a zero displacement means that our object returned to where it started or returned to its initial position. We can find displacement of an object by integrating the velocity or the rate at which something is moving. That would give us our position change, which is called displacement. So displacement could be the same as the total distance, but often is different from the question asking, what's the total distance in which an object or a particle moved? Distance cannot be a negative value. So the only difference here is that we are going to integrate the rate at which something is moving, and we're going to integrate the absolute value of that, making sure it's positive. Our calculator can do that for us and make it really easy. Without a calculator, it takes a few more steps and is a little bit more difficult to do, but we'll do both. So let's look at an example where we can find the displacement change and then talk about how much distance this object moved. So given a particle moving in a horizontal manner with this as its velocity, it's measured in meters per second. We're going to find the displacement after 4 seconds, and we're going to find the amount of distance traveled by this object after 4 seconds. So to do the displacement, we're just going to integrate the velocity. So we're going to find the antiderivative of this function. We get this. And then we're going to evaluate it at the upper limit and at the lower limit and subtract those two values. So plugging in 4 and simplifying, we get 64 thirds. Plugging in 0 and simplifying, we get 0. Oops, sorry. When we evaluate at 4, we don't get 64 thirds. We get 64 thirds minus 34. And then when we evaluate it at 0, we get 0. So I'm just trying to simplify what happens when I plugged in 4. And when we do all that, we could get a fractional answer, or we could convert it to its decimal form, and we find out that it's about negative 12.667, or about negative 12 2/3 of a meter. So since it's a negative displacement, that means that our object traveled to the left, eventually ended up 12 and some meters to the left of where it started, or maybe down from where it started. But this is where it ended up relative to where it started. So this is not talking about the total distance it traveled, just where it ended up relative to where it started. So that's displacement. Let's talk about the total distance this object traveled. So because distance can't be a negative value, we have to make sure and evaluate the absolute value of our velocity function. And we can just plug this into our calculator using an integral function and hit enter, and it'll tell us the total distance at which it traveled, and it will always give us a positive result. So this object traveled a little over 16 meters total. Let me show you how to do it without using your calculator, which is a little bit more difficult. The reason why it's a little bit more difficult is we have to separate the intervals of time at which our object was traveling in a negative direction, separate from when it was traveling in a positive direction. So in order to do that, we need to find where it changed directions. So if I can find the zeros of our velocity, then we can tell where it stopped going left and started moving right, or vice versa. So to find the zeros of velocity, let's factor. We get two solutions. We get +3 and -2, but since we're solving for time, -2 is not a solution that we can use. There's no such thing as a negative time. So we're just going to focus on our object's time at 3 seconds. So at 3 seconds, it changed directions. So let's plug in some values on that interval to figure out, well, what direction was it traveling on that interval from 0 to 3 and on the interval from 3 to 4. If I plug in any value that's in between 0 and 3 into my velocity function, we get a negative value, meaning that our object had a negative velocity, meaning it was traveling left or moving down. And then if I plug in values that are in between 3 and 4 into my velocity function, we get a positive value, meaning that if it has a positive velocity, it was moving right or moving up. So now we know how to set up our intervals with our integrals and make sure that we make this negative integral from 0 to 3 positive. So we're just going to say make it the opposite. We know it's a negative, so we're going to make it the opposite of that. So on our integral, on the interval from 0 to 3, we're going to say the opposite of our velocity function. And then we're going to evaluate our integral on the interval from 3 to 4, just normal, because that's going to give us a positive value. So doing the same thing, we're going to find our antiderivative, and we're going to evaluate it at our upper and lower limits. So plugging 3 into our antiderivative, and then subtracting what happens when we plug in 0. Well, 0 is not there. Okay, so this is our antiderivative evaluated at plugging 3 in, and we're going to make it negative or the opposite of what it was. Then we're going to add our integral and evaluate our antiderivative at 4 and at 3 and subtract those values. So over here is the left part of our equation over here, integrating from 0 to 3. And over here is our integral evaluating from 3 to 4. And this is a big mess that we have to somehow simplify. And when we come all the way down to the end of all of it, we end up getting the exact same answer our calculator gave us by just punching in a bunch of numbers and hitting equal or enter. So evaluating total distance without a calculator is a big mess, but it is possible to do. We just need to make sure that we separate our intervals where our velocity is negative and positive, and make sure that when we evaluate the negative, we make it the opposite. But hopefully we're allowed to use our calculator for these types of problems, and it makes it much easier. So that's the difference between measuring the displacement of an object, which is just its position change relative to where it started, and the total distance, which means that we have to use the absolute value of our rate of change.